Hello, today I want to show you a template project for pybind11, which has unit tests in both C++ and Python, so that whatever you implement in C++ can be tested in C++, and whatever you implement in Python or through the Python 11 binders can be tested in Python with pytest. With this project, you need to clone the repository with the recursive modules flag because there are two dependencies. There's googletest for the C++ unit tests and pybind11, which helps build the Python module out of C++ code. This project has source code that I wrote for a toy problem. If you have intervals in one dimension, each with a start and end, we want to have a set of intervals and be able to do operations and get a set of disjoint intervals in order. So it implements things like and, not, or, and XOR. This is a nice algorithms problem where it's easy to implement the n squared algorithm, but in order to implement operations that go in O n log n, it takes a little more thought. So we have our C++ implementation in these two header files and CPP files, and then our unit tests are in not this file. This is just a boilerplate for running the unit tests, but they're in this tests cboo file. This will create some test cases for us. This is a set of intervals. This is a second set of intervals. If we take the union of them, we would expect it to be a set of intervals with two intervals, one from 1 to 12 and one from 15 to 20. This is all standard Google test stuff, so we don't need to talk about it much, but let me walk you through how we set it up with pybind11 also added onto it. Because also in our source files, we have the pybind11 binder file, and this will take our C++ code and tell pybind11 what Python classes and methods and functions to make out of our C++ code and what they should be called. So that all of that implementation is in this file, and the magic really comes in the Cmake list.txt file. And the point of this repository and the point of this video is that when you create C++ code, in order to make it modularly testable in Google Test, but also be able to build it with pybind11, you need to create it into a static library. That logic is on lines 4 through 11 here. We take our source files and create a static library out of it. These are just compile features and flags. And because I'm running this on Ubuntu, specifically Ubuntu within Windows, but that doesn't matter, we need to turn position independent code on. This will create cboo as a static library, and that's used in two different places. One for the C++ unit tests, and the second place is in our Python pybind11 module. This block of code has some boilerplate for adding Google test unit tests. We add subdirectory to grab the Cmake list.txt file that Google test provides, and we create an executable so that we can run this executable and it will run our unit tests. That executable needs to see the tests we have in test cboo and our main testing file. It also needs to be linked to our static library, cboo, and to the Google test library. It needs to see the header files from our source code, and these are just compile features. And these are more boilerplate lines for cmake.txt. That covers the C++ unit tests. And then down here, we're telling Cmake how to build our pybind11 module. We add the pybind11 dependency, And then we call pybind11 add module, which essentially tells it to create a shared object out of this. That shared object will be called boo.pyb, and that needs to see our binder file, that source file that we went over. It also needs to see the header files from our C++ implementation, and we link it to our static library cboo. That covers the build file. Now let's look at actually building it. Here's my project. And if I call cmake-b build, then it will put all the collateral in this build directory. Let me go into that build directory and call make to build everything. This will, it's already built libcboo.a, that's our static library. Now it's going to build the unit tests, and it's created this executable cboo unit tests. And then finally, it went through and created this boo.pyb bunch of stuff .so file. And we can see those in this directory. There's libcboo.a. Here's our cboo unit test executable. And here is the shared object that is our Python bindings. If I run the C++ unit tests, they all pass. So we have some confidence in the implementation of our C++ code. And that's good to have because we don't want to have errors in our C++ code if we're going to go and use it in Python. So these C++ unit tests help catch issues as far upstream as possible. But we also may need to test things in Python, because in this Python binder, most of this binding is trivial. We're just taking functions and classes in C++ and calling it the same function or class in Python. But sometimes we do put non-trivial implementation in here. Or we implement some code on the Python side and extend the C++ library with additional Python code. This project has unit tests here that import boo.pyb and then test this interval set, the functionality of this interval set class. It has a bunch of pytest style unit tests here, which we can test and run. But at some point I was comparing C++ performance to Python performance. So I also have an implementation of everything in pure Python. And here's the implementation in pure Python. So there's also a separate testing file to test that the Python implementation. There's a lot of redundancy here, not because that's good to have for a real project, but just to show that everything is possible. Implementing in Python and testing in Python, implementing in C++ and testing in C++, and implementing in C++ and testing in Python. These pyboo unit tests are duplicates of the unit tests that are in C++, so they're redundant, but there are real cases where you would want to test some stuff on the Python side. The installation of the Python modules are controlled by the setup.py file, which call Cmake. They will call the Cmake list.txt file, so we don't need to tell it again how to compile all of our C++ code. It will take that .so file that is created and install that in a virtual environment. One gotcha that I ran into is that the Cmake list.txt, when it's compiling, it needs to see the header file. The pybind11 needs to see the header files of whatever Python version you're using. In my case, it's Python 3.8, but you can use, for pybind11, you can use 3.7 or above. And if this is not installed, you can install it by installing Python whatever version -dev if you have administrative privileges. But let's install our Python module and run the Python unit tests, and that will be good enough for today. So we call Python 3.8 -n venv, and we're going to call our environment.venv, and then we activate the virtual environment. And then I install the library with Python setup.py. Oh, whoops, I'm in the wrong folder. I'm still in the build folder. I want to do that in the top level folder. Create the virtual environment, activate it, and now install setup.py. Well, install the library by invoking setup.py, which will invoke cmake list.txt. So you can see it's compiling again. And I actually have it set up to compile all the build targets, so it will compile everything. But now that is all installed, I also need to pip install pytest. And then once that is installed, you can call python -m pytest. -s just makes it print stuff to screen if there's anything to be printed to screen, and run my unit tests by calling pytest on tests. And now all those unit tests run. So again, you can test your C++ code in C++, test the Python bindings in Python, and test any additional Python code you have in Python. And that's all set up with this project. So thank you, and I hope it works well for you.